We are a minute or two after 10 o'clock, so I think we're going to get started. Welcome, everybody. We're super excited to have you all here today. We're going to hear from Meghan about lots of different stuff, but I'm really excited to hear about it all. So I will turn it over to you, Meghan. Thanks for joining us. We really appreciate you coming.
Thank you. Hello. There's a lot of people here. I'm excited. All right, let me try sharing my screen. That worked out very well.
Whoa.
Yeah. Let me get this to present. Everything's in my way. Let's just do it this way. Okay. Hello, everyone. Oh, my name is Meghan Spoth, and today we're going to be looking at climate change in both Antarctica and the Falkland Islands. I'm a PhD student at the University of Maine, so today I'm here in Orono, although my background, I'm already in the Falkland Islands. Is everyone here today from Maine as well? I think so, yeah. Okay, so the big question that I look at is, what is climate and why do we study it? Keep jumping forward. So it's the big question. So what is climate, how is it changing, and how do we study what has happened in the past, and how do we understand what will happen in the future? So with this, climate is a typical weather of a region. So it's the temperatures of the seasons, it's the length of the seasons, and it's the amount of snowfall or rainfall that we get in each of our seasons. So day-to-day conditions that we have are considered weather, but the average condition on a given day over the course of many years is a region's climate. So if you study April 10th every single year for a decade, you can start to better understand what April 10th will be like when it comes around next year. If we better understand our climate, we can better predict the daily weather for our weather, and we can also prepare for extreme temperatures and extreme rainfall events for our region. So if we know what a flood looks like in Maine, we can build all of our walls near rivers tall enough to contain it. Also, if we study the climate, we can better understand our own planet, and we can understand how ecosystems function. So this is very important for chemistry and biology to understand what climate is doing to their systems. It also helps scientists create climate models. It'll predict how climate can change in different regions. So we're going to talk a little bit about how we hear a lot about how much carbon dioxide is in the atmosphere and how that changes temperature. And climate models is what we do to help predict how climate will change versus what it's looked like in the past. So with all the science down, we're going to start doing a little bit more picture heavy stuff. So looking forward, our climate right now is cold and wet in Maine. So Maine is right here in this blue. And we have cold winters, which I think is very true. We have cool to hot summers, and we have moderate rainfall all year long. So that makes sense. Maine has 4 seasons. One of them is very cold, and we have rainfall throughout all of them and some snow in the winter. So to study, we have climate data. So climate data are individual data points that tell us things about precipitation, which is rainfall and snowfall, and also temperature. We often use them as trends, which means how they change over time, averages, so lumping them all together, or extremes, where we're looking at the coldest or the hottest, the driest or the wettest. And we have all this with historical examples. So people write down the weather all the time. So they tell us how much daily precipitation we have, the maximum wind speed, and the average temperature. And then we use that to project it into the future, looking about how much rainfall we might get in a month, and what the average monthly temperature might be. A great example that you guys have probably seen is people look at the almanac to try to predict what the weather will be, but more often we just look at the Weather Channel. But the Old Farmer's Almanac this week has predicted that there's going to be a few rain showers and it's going to be pretty cold. So this week we can all take a look at the weather to see if the climate was predicted correctly. So how do we study the past climate? If people weren't around 2,000 years ago writing down the temperature, how do we know what it is if no one wrote it down? Well, then we have to turn to more natural records. So some of the most relied on climate records are tree rings and ice core records. So when a tree is growing, every single year it grows a new ring. So each of these rings are full of 1 year's climate data. So this really light band right here was grown during the tree's summer months, and this really dark band was grown during the winter months for the tree. So together, these two bands are an entire year of data, and people who study tree rings knows how to translate these tree rings into climate data. Looking down here, we have an ice core from a glacier. A glacier grows each year by having more snow fall on top of it, and all the snow underneath it gets compacted into ice. So people who study ice cores can read this ice core and understand what the climate was for each year of these ice rings that can be very lightly seen in this image. So with that, climate modelers can use this data to look at how climate was in the past, and then climate modelers will project that into the future of what the climate should look like. And it often looks like a chart like this, which is called a hockey stick model. So this is looking at how the temperature has changed from the average temperature of 1960 to 1990. So looking at that, there's a few things we notice on here. One is that our wiggles here go from blue to red. This is the transition of using natural climate records like our tree rings and our ice core records to using thermometers. So in about the 1900s, we started having more reliable ways to measure temperature around us. So that's what that transition is. The other very noticeable thing is that it's shaped like a hockey stick, which is why it's called a hockey stick model. From about 1,000 years ago to the 1900s, we have this relatively flat line that does have some variations that climate scientists call wiggles, which is a great name for what's happening here. So we have these wiggles, and then right about here, it starts to turn upwards. And that's when climate has started to get warmer and warmer. So we have this change in climate, which is where the big phrase climate change comes from, where we're changing of what our typical trends were to a new trend. So we need more and more climate data to better understand what this change will look like for Maine and for other regions around the world. To do that, I'm a scientist that goes out into the field and I help gather climate records to better understand what's going on. So we're looking here in the southern hemisphere. This is everything south of the equator. This is South America, and this is Antarctica. First, we're going to go to Thwaites Glacier here in Antarctica, and then we're going to go to the Falkland Islands. To get down to Antarctica, it's very difficult, and most often people go by boat. So this is a big icebreaker called the Nathaniel B. Palmer, and it can break through all of the sea ice that we see here. So here's all the scientists on board. I'm right here in the front row looking a little bit cold. And it took us about 2 weeks to travel from the southern tip of South America all the way down to Antarctica. And we have a very diverse team of scientists here that were looking at the sea ice. We were looking at the wildlife there. We were looking at the sediment at the bottom of the ocean. We were also looking at modern ocean conditions. So everyone on board was looking at very different things to better understand the climate. And we were studying Thwaites Glacier. So this here is Thwaites Glacier. Thwaites Glacier is this huge glacier that's bigger than the state of Florida. And it's the widest glacier in the entire world. And it ends right here in the Weddell Sea of Antarctica. So we took our boat and we went right up to the base of Thwaites Glacier to better understand what this glacier is doing, because we're worried that it's melting as conditions are getting warmer. So on the boat, we had to live a normal life. We were on the boat for 2 months. So we would go up to the top of the boat and we would look at wildlife. Every morning when I woke up, I would be able to look out my little porthole and see some icebergs floating by. But we also had to do a lot of science on board. So pictured here are some of my colleagues looking at a sediment core. And just like the tree rings and icebergs, it collects climate data over a long period of time because the mud just keeps piling up on the bottom of the ocean. And we're able to take out a whole core of that sediment and look at how it's changed over time. And they found a lot of cool information looking through all this mud. Also, since we were in Antarctica, we had a chance to see some really cool wildlife. So pictured here are elephant seals, and they weigh about a ton. So a whole ton. They're these huge animals, and they're covered in this fur that they were molting while we were there. So all of their fur was starting to come off, like they were shedding like some dog or a bird. We also saw lots of penguins. So pictured here are Adelie penguins. And then we'll get to that. And these here are emperor penguins. So the emperor penguins have a little bit of yellow on them, and the Adelie penguins are super tiny. Like they came up to about my knee, and I'm only like 5'3". I'm not a very tall person. And then here's a little video of the penguins, and this is one of the big elephant seals. You'll also notice that this mama penguin had 2 little babies that were always near her. And you'll notice that everything here is pink in Antarctica, and that's because penguin poop is pink. And penguins poop on everything, and everything is pink. It's just covered in this pink stuff that smells like decaying fish. So penguins are very cute, and we have to keep at least 6 feet away from them so that they can live a normal life. But because penguins didn't smell great, we were more than happy to give them 6 feet of distance at all times. And then also, we had lots and lots of icebergs going past us. Icebergs happen when big glaciers that go right into the ocean start to break off ice from them. And icebergs are famous that about 80% of them are underwater. So this little tiny tip of the iceberg that we see here has a huge chunk of ice underneath us. Some of them are also very big and long. These are called tabular icebergs, and they can be like a mile long. There was a famous tabular iceberg called Larsen C that was the size of Rhode Island that broke off Antarctica, I don't know, maybe 5 years ago now. But these icebergs are very big, even though they're just off in the distance. So when I was down in Antarctica, what I did as a geologist is that I studied these old beaches here. So because glaciers are so big, they weigh down on the earth. They're so heavy that they push the crust of the earth deeper and deeper into the mantle. So when these huge icebergs start to melt away, the ground literally rises up over time. So it can rise up to like 6 centimeters per year. So when you're looking over the course of thousands of years, this turns into a climate record. So each of these really thin lines that we see here in the snow is an old beach from when the earth was pushed down lower by its glacier. So now that the glacier is gone, these beaches are further up this little hillside. So here we are, we were dropped off on these little islands near Thwaites Glacier. So there's the boat going in the distance. So we just had these 2 packs of an emergency tents and lots of emergency food. And we went to work. Each of those little beaches that we saw there, we would look for organic material that you're able to date. So it was a little bit of a I Spies going on. So pictured here is a little tiny penguin bone that came out to be about 5,000 years old. And then right here is a little tiny piece of shell that turned out to be 20,000 years old. So if we know when these beaches were formed using this organic material of living things that are now dead and buried, we're able to see how long it's taken for this earth to rise up. And that's a very important indicator of when the glacier left our site. So this is all very important data that climate modelers can put into their data set to predict future climate. And then here's a picture in the field. This is me very, very bundled up in Antarctica. And this is my colleague Scott, also bundled up in Antarctica. And then pictured down below is my very messy field day after a day climbing over where all the penguins live. So it's a little bit of messy field work, but it's nothing compared to what the people on the boat do with the sediment cores. So here are 2 of my colleagues and me back here, just covered in mud from bringing up these sediment cores, of taking the dirt from the bottom of the ocean. Also on the boat, we did it's called modern calibration. So we study what the ocean is doing today, and it helps us better understand what was going on in the past, if we fully understand what's going on in the future. So this is what's called a glider. These are submarines that people do not go into, and we just put them overboard, and they have all these instruments attached to it. So we can find out which way the water is flowing, how cold it is, how deep the water is, and there's just tons and tons of instruments put all over this glider. And for anyone who likes mythology, this glider was called the Hugin because the Hugin was one of the ravens that would come back to Odin to give it information. And so since we send out this glider and it comes back with the information, they thought it was cute to give it a mythological name. And now next, we're going to go to the Falkland Islands. This was part of my own research where I had a chance to gather data from lake cores. So the Falkland Islands are off the coast of South America. They're also called the Malvina Islands. And pictured here are the sheep. Most people who live on the Falkland Islands are part of the sheep industry. So they raise these sheep, they eat some of the sheep, but they mostly send out wool to people. So here are the Falklands. They're famous for what are called stone runs. And these are these piles of rocks that look almost like flowing rivers, and they flow with ice. So the Falkland Islands are very cold. The summers, it gets up to like 50 degrees at most. It's very cold. It's also very wet in the Falkland Islands. So here we were taking a Jeep across the landscape and we got it stuck about 5 times. So every single time the Jeep got stuck, we would all help and put boards underneath and try to drive it out. So it's very difficult to do field work in the Falklands because everything is far away and over sheepland. But it's beautiful, even if it takes 2 hours to go 10 miles. Once we got there, I went up to the highest peak of the Falkland Islands called called Mount Osborne. And here's looking over the valley underneath it. So it's not a very tall mountain. And then we camped here at the very top where we can see all these rocks. And it's very cloudy and windy in the Falkland Islands. So it's beautiful, but every single morning is misty. And this is where I did my field work. It should look very familiar as my background. And here it's referred to as the black tarn because the water is so full of sediment that it just looks black. So they called it a tarn because that's what any small pond within a glacial cirque is called. So this whole bowl used to be filled with ice about 20,000 years ago, and it was ice that went all the way up to the top here. And over the last 20,000 years, this glacier has melted away and there is no more ice here where we're studying. And we're using these sediment cores to understand what happened. So here we are, me and Dr. Tom Lowell. We're out on our little tiny inflatable Zodiac, and we were able to take a long piece of sediment, so all this dirt in its correct order, out from the bottom of our pond here. So looking at that, I brought everything back to the University of Maine. So here's one of our sediment cores. This keeps jumping ahead. Is one of our sediment cores. So we see here that there's these little bands that look almost like tree rings that happen. So it changes in color. Some of these are different thicknesses. Some of them are bright white. These super bright lines here are called tephra events. And it's when ash from South America had a huge volcanic eruption, and all the ash comes over and it settles in the Falkland Islands. So this is volcanic ash here. So it was that point where the whole lake that I'm studying was just covered in ash that slowly sunk down to the bottom. And now I can date how old this is. And I know when a volcanic eruption happened over 6,000 years ago. And then I do all of these other lab work. So most of my time, while I do enjoy going out into the field, is spent in the lab. So here I'm looking at how magnetic my core is. So if something has a speck of iron, I'll have a peak in my record. And if something just has a bunch of carbon and just like organic stuff, it's not going to be magnetic. And I'll have a little dip in my record. Over here, I take little tiny pieces of dirt and I put them in an oven and I burn off all the water, and then I burn off all of the organic stuff. So any little bits of fish that are stuck in there or little bits of vegetation gets burnt away. And then I can study how much organic stuff was living in my lake. So did I have a lake that was full of fish? Did I have a lake that was full of vegetation? I can look at that by just burning off bits of the dirt. So some of my lab work is very, very fancy, and some of it is very low tech that I could probably do in my kitchen at home. So it's a fun mixture of stuff that I do with my sediment record. And then over time, I take everything that I study and I'm able to do a climate interpretation. So I know that during the LGM, which is the last glacial maximum, which is when ice was full in that little tiny basin that we were looking at, my record tells me that it's cold and windy. It makes sense. If I have ice growing, it's probably very cold. And the termination, which is a fancy name for when the ice goes away, it was warmer. So a lot of these things start to make sense. And then throughout my record, I can look at more complicated stuff, like whether or not it was windy there, how dry it was. And I can do all that by understanding that when the basin goes empty and there's no more water in it, it has to be drier conditions than today, where I have a lake in my area. So with all that, I'm able to, let me move this over. I'm able to help the Falkland Islands understand how their climate is changing. Sorry, my dog is needy. I'm able to understand how the Falkland Islands climate is changing so that farmers and fisheries can better understand what's going to happen to them in the next few decades. So if things are getting warmer, like climate models are so far predicting, farmers might know that they can't rely on winter to freeze everything over to transport stuff. And fisheries are going to have to worry about how ocean currents are going to change. So with all of that, my data set can help everyday people really look how the future is going to look for them. So I'm super excited to work with other climate modelers to better predict and help these farmers and fisheries understand what's going on. So with that, I have a few extra moments. So we are going to go through the videos really quick. So this is my penguin video. We had to take a break during one of our lunches because the penguins, I guess, have a march that they do every day at like 1 p.m. and they just crossed our field site. And since we're not allowed to be near the penguins, we just had to take a break and let them pass by. So, and then we have a few stragglers coming along here. Okay, and then we've seen this video, but it's cute enough to show a second time. Okay, and then we can get into that later if we want. Okay, I can either take questions now or I can show a 360 video that I have and do questions after that, whatever order we want.
It's totally whatever is better for you. We've got some questions here in the chat if you'd like to do that, and we can save a few minutes at the end to show the other video. If you'd like to show it, we can do that too.
Perfect. Let me just get, oh, I have to stop sharing my screen. There we go. And then this is Roxy here. She came in. There's some loud noises outside.
Well, the first thing I just want to say is we have a couple different students saying that everything that you just talked about was amazing and they think it's super cool. So I just wanted to share that with you, which is awesome. But we have one student who's wondering about, is land rising a problem for people? And they want to know more about how you could tell that's happening.
Yeah. It's not necessarily a problem for people. The place that it's happening that the most people live right now is Iceland. So Iceland is slowly rising up, and not a lot of people live near the coastside where the glaciers are retreating, because Iceland is famous for these big floods that happen as the ice melts underneath the glacier, because there's volcanoes underneath the glacier. You get these huge floods that are called gullops, where water just floods out, and it's this huge flood. So I haven't heard anything about the rising land affecting people directly. It would change who has beachside property. Like if you live on the beach and you leave it to your family, your grandkids may no longer live right on the beach. There might be another half mile to walk down to the beach. So I don't think that affects people, but it would be something that people would notice. And a way to understand it is if sea level isn't rising, which isn't always the case, you can actually see that the beach that you used to have is now further upland. There's a few hikes you can do in Acadia where as you're hiking along, you all of a sudden start to see these arches that were carved out by waves about 20,000 years ago. I think it's called the Stewart hike in Acadia, but you can see where the ocean used to be meeting it. But because Acadia itself has risen up out from the ocean, because we used to have ice sheets over Maine, you can see some of that in Maine. But it doesn't quite happen fast enough for an individual human being to be affected by the land rising.
Awesome. Then we have actually a couple classes who are wondering, how do you estimate how old sediment is, and how did you learn how to do that?
Great question. To find out how old sediment is, the most common way to do it is called radiocarbon dating. So when I have my big long sediment core, I'm able to pick out little bits of stuff. Like sometimes I can find a little bit of a fish that died a long time ago, or a little tiny piece of bark, or like a stick or a twig. And then I take it and I send it to someone who has this big giant centrifuge. And this centrifuge is this big circular thing that spins stuff really fast. And just like how you spin stuff, liquids will sometimes separate out. If you spin something fast enough, all of the little atoms inside of something will also separate out. So through a very complicated process, when things get older, any bit of radioactivity that's in it, like we're all full of radioactive carbon, and it's natural and normal, and we need it. But this natural level changes. And depending on how much this natural level changes, we're able to fit it to a curve that scientists have worked very hard on and determine how old something is. So by looking at the carbon isotope ratios, which is a very scary phrase for just saying how we separated out all those atoms in our big giant spinning centrifuge, tells us how old something is. And I learned to do it by working with a lot of great other scientists. And there's a lot of great options in Acadia where they bring you out there and they can core stuff and they can show you what they're going to sample. It's a little bit harder to see the radiocarbon process, but there's lots of people who are more than happy to show you what they're going to be sampling and what those dates turn out to be. Like on that beach there, we had those little bits of penguin bones, and those turned out to be about 6,000 years old. And those little tiny bits of shells turned out to be 20,000 years old. So it's exciting to see how some things haven't changed as much as we think they did in the last 20,000 years.
Awesome. And then on the kind of same train of thought, a class is wondering, what's the oldest sediment that you have found so far?
Yeah, my oldest sediment is 23,000 years old.
Wow.
So that was exciting.
Definitely
And my
cool.
oldest volcanic eruption was 10,000 years ago.
Super cool. Then we have a couple questions kind of about fieldwork and what it's like to be in Antarctica and all of that. And one class is wondering, how much clothing did you have to pack and how many layers did you need to wear to stay warm?
Yeah. So they gave us some of our equipment. So they gave us like fleece lining pants. They gave us like big Carhartt canvas jackets to wear because the work is hard in Antarctica. You don't typically always want to wear your own stuff that's going to be ripped and torn apart and covered in penguin poop. But typically when I went outside, I'd be wearing some sort of like base long underwear leggings. I would have some sort of fleece pants. And then I had these insulated canvas overalls that I would wear. And then on top, I would be wearing another base layer. I would have some sort of like cotton t-shirt, and then I'd have a fleece sweater, and then I would have a big windbreaker jacket. So because you're right on the ocean in Antarctica, whether you're on the boat itself or on the little islands, it's always windy and there's always just icy water everywhere. And because we took the little Zodiacs to land, once you had all of that on, you had to put rain gear on top of it because everything would splash in the boat. So we would be pretty geared up, and then we'd always bring hot water and hot coffee to drink out there to continue to stay warm.
I can imagine it would be really chilly.
Yeah.
Then we have some students wondering, what was your favorite thing that you saw when you were doing your field work?
It was very exciting to see penguins. I don't study penguins, but it was exciting to see penguins. There's also a lot of whales. It's very hard to take a picture of a whale because they look so big every time you take a picture. They're so tiny. But we spent a lot of time in the boat during free time. We would be up at the very top of the boat looking out, and everyone who studies the wildlife would just start pointing out all the different types of whales. So there's lots of minke whales. We saw a few humpback whales, and it was exciting. I'd never seen a whale before, so I was excited.
That is super cool.
Yeah.
Then we have a class wondering, I know you said you didn't study penguins, but if you know what makes the penguin poop pink.
It's something, the fish that they eat a lot of that krill, and I guess the krill themselves are pink. So I guess just through the food chain, it stays pink. So the fish that are eating the krill determines the color of the penguin poop. But it smelled like fish, so it was a very believable tie.
Then we also have a student wondering how many weeks or months were you in Antarctica?
I was in Antarctica for a total of 6 weeks. And so it takes like a week and a half to travel from South America to Antarctica and then Antarctica back again. So once you take all your travel time, it felt like a very short period of time in Antarctica itself. And unfortunately, you have to plan a big trip if you're going to go somewhere that remote. Like we had lots of bad weather days where we just had to give up doing all science because no one was allowed outside of their rooms.
Yeah, awesome. Then we have somebody wondering, when did you know you wanted to be a scientist?
Yeah, it's a good question. I've always been interested in outdoors. I'm not from Maine, I'm from New York State, but I had a chance to really be outside a lot as a kid. And I loved going through our local pond and catching all the frogs, figuring out what kind of frogs they are. And I just always had questions about what was going on around me, like why was the mountain there? Why was the lake here? And as I went on in school, I was always drawn towards science because it was answering these questions that I just had questions about. And then from there, when I went to study in college, I started off in biology because I loved looking at all the animals, but I kept getting nagged by those big questions, like why is the mountain here? Why is the lake here? Why did it change? And it brought me to climate science and geology, which looks at those big questions, but I still have a chance to work with natural things in biology and chemistry. So geology was an answer to studying all the big questions that I wanted.
Awesome. And then kind of in the same train of thought, I think if someone's wondering, do you think you want to keep doing this research after you're done and get your PhD, or do you want to switch gears and study something else, or do you not know yet?
I don't know yet. I've helped out with a broad range of collecting different climate records and working on them in the lab. I think this field is broad enough that it's going to be very hard to get bored of it. Like if I get tired of lake sediment cores, I can always learn more about tree rings. And if I get tired of that, I can study ice cores. So this is a really broad field and I like all the big questions. So I hope to stay involved in it, but I'm also excited to help teach people how to work with these records. So in the future, I hope I'm a little bit more geared towards getting new people started on studying these records and still having a chance to go out into the field because it's exciting to see the world through little remote places.
Yeah, that is super cool. Then we have a class wondering, so how do you get the sediment from so far down? How do you actually collect the cores and pull them out?
Yeah, let me see if I took an image of it. We did not take an image of it. So we have this long instrument and it just looks like a giant metal straw. So we have that and we take it on a boat and we get it vertical, which is an event. So once we get it actual vertical, where the straw is pointing down to the water, we take it and we put it down to the bottom of the lake. So the bottom of this will be touching the top of the sediment. And then there's a few different ways to do it. We have one that we use that was called a piston core, and it's just sort of like a little air gun where you just push it down and it just rockets itself down. And then you have a little clamp at the bottom and you pull the whole thing up and then you just have like a straw of sediment going on. They also have what's called the vibrocore. And we made one when I was studying climate in New York. And it was a part of a lawnmower that we took apart and we put it on top of this metal straw. And when we turned it on, it slowly vibrated itself down into the sediment. So there's lots of creative ways that scientists work with engineers to figure out better ways to collect the sediment so that it's safe for the scientist and that we also get good data. So there's a lot of ways that you can mix up that dirt because the dirt wasn't made to be collected by scientists. It was just made over time. So it's another great way that we collaborate with engineers who can look at these problems that we have and help provide us answers.
Awesome. Then we have some more questions about the penguins. We have a class wondering if you could tell the names again of the penguins that you saw down there.
Yeah. Let me reshare my screen and just do it that way. Perfect. Sure. Okay. I think this is the best one to look at. I've heard a few different pronunciations for this, but I've been calling them Adelie penguins. They're also called Adelaide penguins. I think it's a difference of British and American pronunciation. I was on a boat with half British scientists, half American. So there's some pronunciation difference here. And these with the little yellow mark are emperor penguins. And I'm pretty sure they're the tallest penguins. It might be king penguins, but I'm pretty sure it's emperor penguins. King penguins also have that little yellow orange bit on their neck. But yeah, these were the two penguins in the region where we were studying. There's more penguin types overall in Antarctica, but we were just in this little tiny basin called Pine Island Bay, and these are the penguins that inhabit it.
Awesome. And then we have a student who's wondering, you said the Adelie penguins were really short. So they're wondering how tall are the emperor penguins in comparison?
The emperor penguins, I was never near one. I forget. I feel like someone told me they were 5 feet tall, but I don't know if they were preying on me not knowing a lot about penguins. So I don't want to say that as a fact, but they're very tall compared to all the other penguins.
Awesome. I think right now might be a good time if you want to show those 3D videos. That'd be really awesome for everyone to get a chance to see, and I just don't want to run out of time.
Okay.
Yeah, so Megan has some really cool videos that she wanted to share with everybody. So we're going to get a chance to see those, which will be great.
Oh no, it's sideways. Okay, let's see if I can do this. Okay. Library, Orsons. Okay, so first we're looking at Punta Arenas, which is the most southern city in South America. I hope it's not as blurry on your guys' screen as it is for me. But this is the city itself. There's me crouching with my little 3D video. And it's a very old town. So this was founded by everyone that was traveling and trying to circumnavigate the world. So this was founded by various sailors over the time. So there's, they speak Spanish, it's part of Chile. So Spanish is the national language, but it's also found by the Spanish of Spain a lot. So there's a lot of very traditional Spain architecture going on there. And then this is the seawall. Because we're close to the ocean, this here is the ocean, there's a lot of tectonic activity offshore, so they get a lot of tsunamis that come through. So they just have this little wall to help start, and then there's lots of alarms and signs about what to do if a wave comes. And then this here is the ocean. This is a little bit of a beach. And then way off in the distance, you can see the yellow and red boat that I took to Antarctica is docked and ready to go. And as we look along here, there's a giant casino along the shore. And then back over there is where all the fishermen come and sell. Oh, sorry, you can't see me touching. That little shallow white building a little bit further back than the front white building is where all the fishermen come to drop off their fish. And it's just this giant fish market where you can see all these crazy kinds of fish. So this is Punta Arenas, and this was my starting point for the trip. This here, as it loads, is the top of the Palmer. So this is standing on the bow of the boat, basically Titanic style, and you're looking out. So right now we're fairly close to South America. This here you can see in the distance at land is called Tierra del Fuego, and it's a little island at the base of South America, and it's a beautiful blue sky day. So everyone's allowed outside. Those are one of my colleagues. I think it's Scott. But here we see this huge boat. So it's about 5 stories tall. It's hard to tell with this, but it's this huge boat. And then I showed that picture of me and my colleagues sitting on chairs. And that was happening right up in that galley where all those windows are. And that's where the captain also sits with his giant computer. Unfortunately, there's no big steering wheel. He just has a giant computer in front of him that helps him navigate, and he uses satellites. He uses radar underneath him. He has every single instrument of navigation that you can imagine in front of him in that area. His name was Brandon. He was also a cattle rancher in Texas. He was a very interesting guy. But yeah, he got us down to Antarctica and back, and he got us right up next to the glacier. So now we're going to jump all the way over to the Falkland Islands. And this is where I did all my research. So this is one of the tarns up at the very top of the mountain here. So as we can see here, a tarn is just a pond with this huge head wall. So a glacier 20,000 years ago carved out this bowl and just made this giant place. And as the glacier started to melt away, it filled in this lake basin. And then I study all the sediment cores to figure out what's happened since the glacier has been here to today. So there's me with one of the, you can see there, that's one of the vertical poles that we use to shove into the sediment. And then there's my two advisors there helping and guiding me through the process. And then all of these rocks here, this should look very familiar to everywhere in Maine. All of these rocks were just dropped by the glacier. So these glacier carved out this big area, grinded up this cliff into these little tiny rocks, and it just scattered it everywhere. So just like Maine had its giant ice sheet that carved out a lot of our areas and just left these big rocks everywhere, my glacier up here did the same thing. And then all of these big lumps of sediment are called moraines. And that's where the ice had stopped at one point. It just kept dumping and dumping and dumping sediments and rocks and just dirt and powder. And so it built up these huge like lumps of hills everywhere. And then, oh, yeah, we skipped this one. And then this is base camp. So up here is on my way up to one of those big lump moraines. And then over that is going to be the mountain itself. And then here are all the little tiny tents that we stayed in. So we camped out, and then there's me bundled up. We camped here for 2 weeks. Once again, we have all the rocks everywhere because the glacier also dumped rocks here. This is a little four-wheeler that we took everywhere to travel since we had some really heavy equipment. And then this is my tent. And you'll notice that it's covered in rocks. And that's because my tent blew away. It's very windy in the Falkland Islands, and everything is just always just constant wind. So my tent had started to roll away, and I did not like that at night. So we just covered it in rocks to keep it from happening again. We found out later on that my tent was the wind block for everything else. So, but yeah, so that's just a look at some of the places I've been. And then we've seen this one. Cool. So let me stop sharing my screen on this one. Where's down? There we go.
Awesome. Well, I think we are unfortunately right at 10:45, so actually that was kind of perfect timing. But I just want to say thank you to all of the students for coming and listening and asking such great questions. And thank you to you, Megan. That was really, really interesting. And I think everybody learned a lot of different stuff. So we really appreciate you taking the time and talking to us all today.
Thank you. You guys had great questions. Those were some really good ones. I'm going to have to look up how tall an emperor penguin is. Now I really want to know.
Yeah, for sure. Well, I hope everybody has a wonderful rest of your day, and thank you all again.
Thank you.